Hi again. So this will be our last set of lectures on feminist critiques of the sciences. We'll move on to realism and anti-realism and race next week. This lecture again should hopefully be short, around a half hour. We're probably all getting sick of talking about gender, although I think this is really cool research and there's lots of really interesting things around this topic. But anyways, I wanted to spend, because we spend a lot of time picking on the biological sciences, and the psychological sciences, in relationship to biology over this section. But I wanted to talk about another science. I wanted to talk about neuroscience. And there's been a lot of work that's really interesting around the neuroscience of gender and sex over the past couple years, really in the last decade. And I wanted to highlight the work of Cordelia Fine, partially because she's an Ivy League professor. So she's very well respected. Her work's really interesting, and her work's really accessible. So if you want to know more about the science of gender and sex, she's somebody you can definitely look up and study her work. And you don't need a degree in neuroscience to go read her material. But she's taken on a lot of the ideas we have about essentialism about gender, about the idea that gender and even sex are sort of naturalistic properties, and they are essentially one way and only one way. The males are fundamentally one way, females are fundamentally another way, and that there's no sort of fluidity between these two things. And it's just a matter of the way our brains are and the way our biology is. She's challenging that from the perspective of a neuroscientist. So, Cordelia Fine's contemporary neuroscientist who's argued that much of what passes for the neuroscience of gender, she argues, is latent with sexist assumptions and biases that make the word nonsensical or at least false. So what she's doing is she's looking at, she's raising very similar concerns to those that we've seen around some claims in evolutionary psychology and biology, except her focus is on claims about male and female brains in particular. And so what she's really arguing is, look, the neuroscience in this area, whether it's intentional or unintentional, it really ends up being pseudoscience. And much of the claims that we make today, or even that scientists are making today, about women having specific kinds of brains and men having specific kinds of brains, just really aren't supported by the data. That's what she's going to claim. Now, there's a long tradition, and we've, I think, talked quite a bit about sort of the history of sexism and the way we've thought about men and women. But there's a long tradition continuing right to today that men and women are fundamentally biologically different, and that this impacts our brains and our minds, right? So here's not, it's not a claim like, well, males are, have more muscle mass or something like that, and so they're stronger in theory, or something like this is the way our brains work, is the claim, right? And the claim is that male brains are radically different than female brains, and so they're suited to different kinds of tasks. There's been a lot of neuroscience that has been published in the past about 2 decades that would lend some credence to that claim. She's going to challenge that stuff. But very common myth: males are better at spatial and logical reasoning. Females are better at communication. They're more emotionally intelligent. Fine's going to look at, well, to what extent is that myth sort of really true? How much is that sort of backed up by our neurology? And how much of that, to the extent that there is a truth there, that statistically males are better at spatial and logical reasoning, females are better at communication and emotional intelligence. Even if that is true, how much of it is social, right? There's this classic debate about nature versus nurture, right? She's gonna come pretty hard down on the side of, to the extent that there are differences here, they look like they're almost entirely nurture, not nature. So there's a question: do we have gendered brains? So 2 really commonly held assumptions in a lot of the work in this area is that the biology of males and females is distinct in ways that predispose males and females to stereotypical gendered behaviors and thoughts. These behaviors are natural, they're essential, right? They are fixed, they are invariant across time and place. They are due uniquely to female versus male brain circuitry that is largely fixed by a sexually differentiated genetic blueprint. She'll challenge that. And she says, look, today, if we start looking at the neuroscience here, actually these assumptions are coming under attack. There's been several major research projects in which the brain sciences have really reevaluated this, right? And she thinks it's critical to reevaluate previous experimental findings and to design our future science studies of our brains outside of this, binary male-female dichotomy. She's going to argue, look, when we start being really careful, we'll see that any supposed differences here largely disappear, at least in regards to the neurology and the biology. She says, look, gender scholarship can hasten scientific progress. We can get closer to the actual truth. We can be less wrong by revealing implicit assumptions that we have that might give rise to neurosexism. And she says, actually, there's been a lot of this gendered research that's been going on over the past couple of decades, and it's really changing things. It was long thought that traits, interests, and social roles were gendered, right? Males are aggressive, females are empathetic, females are better at empathy, males are better at spatial reasoning, females have a natural interest in the arts, males in the sciences, females are better caregivers, males better leaders. And these roles, again, are unchanging, they're natural, they're essential, they're immutable, right? Those are the assumptions. And she says, look, these are being challenged. Our traits, our abilities, our attitudes, our interests, substantially overall in the majority of gender characteristics, substantially vary overall in the majority of gender characteristics. And the different feminine and masculine characteristics are at best weakly correlated, right? So when we say there's a weak correlation, we say there is a slight statistical difference between, the things we're talking about that shows up in the data, but it's a weak correlation. It's not the kind of correlation that would suggest causation. It's a kind of correlation that suggests that there's probably a third factor or something else going on behind the scenes, right? And it's also not a very strong one, right? And that's important, right? When you have a strong correlation, correlation is not causation, right? So correlation never establishes a causal connection. You need further argument and you need further kinds of evidence to get from, hey, look, there's a correlation here to we think there's some sort of causal connection. When you have a weak correlation, it is really unlikely that you have a causal connection. What is almost certainly happening when there's a weak correlation is that there's other things going on behind the scenes that are to account for any apparent difference. When we have a strong correlation, what we can say is, look, this factor, being male or being female, is really, really tightly connected to this kind of a difference. And so while that doesn't prove causation, that gives us reason to think that there might be a causal connection there. And then we can start looking into that. But weak correlation, generally the way you go with a weak correlation is you say, okay, well, these things are related, but it's probably a spurious correlation, or there's something else that's accounting for this connection. And she says, look, the new picture that is emerging is not one of male versus female, but rather of a complex mosaic of both what we call traditionally male and traditionally female characteristics in a pliable, changeable, mutable brain. And this is the picture she's going to try to give us, right? Is that we're much, much more complicated, and these ideas we have about gender are much more fluid and changeable than we might think. And that suggests they're not essentialist. It's not that males and females have fundamentally different brains. Something else is going on, right? In other words, gender is not essential. It changes across time, place, group, and context. Likewise, our studies of brain development are also rapidly changing, right? Brain development is not, say, hardwired male, female, right? It seems to be the picture that's emerging. Rather, what we see is that there's a quite complicated developmental process in which brain development is influenced by our experiences. We have, you might call plastic brains, right? When we talk about plastic in regards to the brain, what we mean is that something like neuroplasticity, what that means is that there's a number of different sort of ways in which our brains can accomplish the same tasks. And there's a number of different ways our brains can develop. That's a bit of a simplification. But the idea is it's not hardwired in, it's not fixed, it's not static, right? Like, so your heart's a static thing. Your heart works in a very specific way, right? It biologically develops in one way. And then unless it starts breaking down and we need to intervene and fix it in some way, it works in that one way. And that doesn't change with environment or any other sort of development. Something that's mutable, something that's changeable, right? uh, is dramatically influenced by environment and experience. And so the picture she's giving us here, at least as what she thinks is the developing view in the brain sciences, is our brains are much, much more plastic, much, much more changeable than we historically have thought. Now, all that said, it does seem that biological sex is a part of this. It does play some role in how we end up being, right? So it's not like she's arguing that there is no difference whatsoever between males and females, even in regards to our brains. But what she's saying is, look, it's just one factor in a really, really complicated dynamic model. And that it's a mistake to sort of think that what's doing most of the work, or even like a significant amount of the work, is the male versus female brain. She says we just don't have data that would support that, is her claim. She says sex influence gives rise not to distinctively male and female brains, but rather to a unique mosaic of male and female characteristics. Think back to Helen Longino, right? And how she had these pools of ideas that were available to people based upon their situatedness. Cordelia Fine's got a very similar kind of idea about what it means to be male and female, right? It's just that, you know, there's a mosaic. There's this large pool of ways in which you might say have male and female characteristics, and often they overlap between the people that we think of as biologically male and female. And so the idea that there's these really hard, tight demarcations between the two sexes in regards to our brains is not supported by the data. That's what she's going to say. There are no essential male-female characteristics in regard to brain development and subsequent behavior and preferences. To the extent that there are differences, it looks like they're mostly environmental and social. And that to the extent that there are gendered brains, because again, she'll say there absolutely is, but it looks like they're created. We start with brains that are, for the most part, very, very similar. To the extent where somebody who has a male brain that diverges somewhat from, you know, like to the extent that there could be more in common with, say, somebody that has a male brain and somebody that has a female brain than there is between that male brain and another male brain, right? Like to the extent that there are any differences, it's very, very fluid, is her claim. And so when we sort of emerge as adults, right, when we get to the point where we're, oh, I'm a male or I'm a female, and that's how my brain operates, well, it looks to Fine like this is mostly the gendered process of an environmental and social factors. So that's the picture that she thinks is developing and becoming more and more the mainstream view in neuroscience. And she says, now, despite all that, neurosexism is all over the place, and it still persists even within the field of neuroscience. She says a lot of research on the brain is conducted on this old assumption of gender essentialism, that, you know, males are a very specific way and females are a very specific way, and that's just because of our biological nature. And then she points to some examples. There's a recent study that used imaging technology to assess sex differences in neuronal connectivity in children and adults. And this data indicated greater connectivity within each hemisphere in males and greater connectivity between hemispheres in males. So that suggests radical difference of organization within the brains, right, and how they process information. So it looks like, and I mean, that kind of data on the surface says, hey, look, it looks like male brains really are significantly different than female brains. And the researchers that did this speculated that, well, male brains are structured to facilitate connectivity between perception and coordinated action, whereas female brains are designed to facilitate communication between analytic and intuitive processing modes, right? And there you see those traditional gendered brain assumptions, right? Female brains are better at communication, and they're better at empathy, right? And they're better at intuitive thinking, right? Creativity. Whereas the male brain on this picture is much better at sort of perceiving the environment leading to coordinated activity, right? Much better at logical information processing, spatial reasoning, that kind of stuff, right? And this data is used to speculate about psychological differences between the sexes, right? And in other words, these results are taken to demonstrate hardwired sex differences that support adult stereotypes. And Fine looks at this data and she says, well, when you start looking at the data, this is a mistake. for a number of reasons. First of all, their data did not look at brain behavior correlations. They're speculating to brain behaviors, and they really need to be looking at connections between brain and behavior if they're going to make these claims. They don't have that. They did not look at the role past experiences played on brain and behavior solidification. Now that's important, right? Because what they're doing in this data is they're saying, look, there's these fundamental biological, natural, essential differences, blueprint-wise, between males and females. But if they didn't look at, the role experience played in brain development and within sort of neural connections within and between hemispheres, well, they don't have the data at all, right? Hopefully you can see that, right? Like they literally don't have the data that would support the claim that it's biology and not environment. Because it's a weird thing about neuroscience, but I mean, every experience we have, everything we do, right? When you learn something, when you experience something, right? Like when you do something, you form new neural connections, right? Your brain is responsive to the environment you are a part of, right? So an equally compelling explanation of the data here is that you could have a social environment such that children and young adults that are female are more likely to experience situations that lead them to form connectivity between hemispheres, whereas male children and male young adults are more likely to have experiences that lead them to form connections within each hemisphere, right? That's entirely consistent with their data. And there's nothing here that speaks for one or the other. So he said that's a big problem, is our research is just assuming that one way of looking at these problems is the correct way to look at them, but we just don't have the data to do that, right? And so it really nicely, I think, sort of illustrates a lot of the problems that feminist critiques of the sciences have been pushing over and over again, right? Certain ideas are not available to certain research communities, right? If you're not looking at certain kinds of things, you'll ignore them. Right? You bring your own biases to the table, you interpret, you don't consider other alternatives that are equally plausible. And so because of that, your research ends up fatally flawed. So her point, look, it's equally plausible given this study here, which seems like really compelling evidence for male versus female brains, that socialization was fully to account for any differences in the brains, not hardwired sex differences. And because they don't have any data whatsoever that explores that possibility, they can't rule that out, right? So they're no more justified in making the claims they are than somebody would be looking at this data and saying, actually, this data just shows us that socialization plays a tremendous role in the kinds of brains we end up with. In fact, when we start looking at this kind of data and we put it in the context of, say, computer science or artificial intelligence research, right? Our current models of how neural nets work, right, and how machine learning works, suggest that, look, our AIs learn and develop over time. They are neuroplastic in the same way that some people think we are, right, and we almost certainly are. And so that suggests, look, we already have models that are really complicated in AI research of things that sort of respond to their environments and learn to process information in different ways, not because they're hardwired in certain ways, but because they interact with their environment in certain ways, and that leads them to be that way. And so why wouldn't that extend to something like us that's doing the same kind of information processing? Really important to consider that possibility. It's not considered a big problem. So Fine says, look, now there's that problem, but we've also got some other issues. She looks at some other studies that are used to demonstrate the same kind of things. And she says, so there's an earlier study where researchers reported behavioral sex differences in executive control and memory and reasoning, spatial processing, sensorimotor skills, and social cognition, again, male versus female brains. This was in a larger sample from which these participants were drawn, right? And she says, look, in that study, the differences were very, very modest. When we had a really big group, right, we were getting closer to a representative account of our population. And 11 of the 26 effect sizes disappear once you get a big population. And the largest effect size was really tiny. It was barely statistically significant, right? So despite the substantial behavioral similarities between the sexes in these earlier research studies, the researchers interpreted their findings in a radically different way. They said, look, they underline profound behavioral differences between the sexes, again, without looking for brain behavior correlations. So she says, look, this study here, this really seminal study that, is supposed to be, this is sort of like a smoking gun. She says, this one's really poorly designed, doesn't demonstrate what it's supposed to show. Then you get a really small sample size. It's a big problem. And she says, now, if you go to a study that's got a bigger sample size, it looks like most of these effects just disappear. And to the extent that there are differences, they're not overly statistically significant, right? It depends on how you modify your p-values and stuff, right? Whether or not you're going to see these results as significant or not. And so she says that's not super compelling. And then she says, but despite that, the researchers make the same claims, is that these studies demonstrate beyond a shadow of a doubt that males and females have different domains. Which is that, as a neuroscientist, I can't say that. We just don't have the data that supports that conclusion. And again, she's not one person, right? We're looking at her because she's accessible and she's representative of a significant research community within neuroscience. So really what we're saying here is, look, there's this big debate within neuroscience today about whether or not this is really the case. People like Fine say absolutely not. She says, now, despite all that, essentialist assumptions might work in less overt ways as well. To influence the way we do our research, right? So she says, so here's two seminal studies. It looks like neither of them can really establish these claims. We really need to be doing different kind of research if we want to sort of find a way to account for supposed differences between men and women and figure out whether or not they're really biological or environmental. And then she says, now there's other ways in which kind of assumptions about essentialism about gender and sex might influence our literature as well. And so she says, look, there's this really influential literature review of fMR studies conducted in 2009 through 10 that looked at sex differences. And they found that 3/4 of those studies were done on groups of less than 16 participants. Now, hopefully we realize, I mean, you're somewhere in the middle of your degrees. If you've got a sample size of 16 people, that's really tiny. That's something to be worried about. Now, if you were looking at something that was really like if you were looking at a population that was really homogenous, everybody in that population was basically the same, you can have a small sample size, right? So a general rule about statistics, right, is when you're looking at homogenous groups that are basically the same, you don't need a huge sample size. But to the extent that your groups are heterogeneous, right, they have a lot of diversity within them. You need really, really big groups. It's one of the reasons that polling for political, who are you gonna vote for in the next election, right? It's one of the reasons why polling is notoriously unreliable, is because voters are a massively diverse group, right? We are very heterogeneous, right? Like even if you look at even if you look at all professors or something like that, right? You look at school teachers, right? How are teachers gonna vote? In a province like Alberta, where we, have, traditionally governments that are very hostile to education or something like that, right? You would think you'd have a lot of consistency in educators in Alberta and how they would, but I mean, that's not true. There's massive diversity within even a group that's fairly uniform when it comes to people, right? And so we just have a problem when it comes to voting is, voters are so diverse. You need massively large sample sizes to get sort of reliable information about how they're going to vote. And it's really difficult to do that. And even if you have a big sample, it can often be wrong. And so, but that's just a general rule about statistical inferences, right? If the things you are looking at have a lot of diversity within them, then you need really big set studies. And 16 participants is a really tiny study. And so, look, if brain differences in females and males were highly distinctive, right? Like almost all women were exactly the same and almost all men were exactly the same in regards to our brains. And we know that's not true. right? Even if there are male and female brains, we know that there's a lot of diversity within women and a lot of diversity within men, right? And definitely across each other. Um, but if they were like sort of really, really clear in that way, right, then, maybe we could have fairly small sample sizes. But if there is a lot of difference, which there is, even if you think that, there are fundamental differences between men and women, there's still a lot of difference, right? Um, then you're gonna need really big studies. And what she's saying is, look, the vast majority of these studies in a lit review had really, really tiny groups. And so what does that mean? That means your statistics are not representative. Um, and what do we do when we have an unrepresentative stat? We should throw it out, right? We should say, well, this doesn't represent the population we're talking about. It's it would be BS to take it as telling us something interesting. And that's a problem with statistics. It's really easy to kind of generate stats to say whatever you want, and then even when we know they're not representative, like take any poll done by a newspaper, right? Newspaper polls are not representative. They can't be. They're basically like astrology. They're done for fun, right? Like if Fox News or the Red Deer Advocate polls their readers, they're not getting a representative sample of voters or Albertans or what they're doing is they're getting a sample size that's really small for one, and it's a sample that's skewed towards certain kind of views because it's their audience, right? So the people that read the Red Deer Advocate are the people that take part in polls conducted by the Red Deer Advocate. That's not going to be representative of the population, right? That's going to be skewed towards that market. So unless that's what you want to know is, well, what does our market that buys our newspaper think, right? You're not going to have reliable data. And so to use that as if it's a scientific result is just a fundamental mistake, right? That's one of the cardinal sins in statistics. It's unrepresentative. It doesn't actually mean anything. And here the claim is quite damning, right? I mean, to the extent that this is correct. If the vast majority of your studies are not representative, well, it's not like you can even pretend to take them seriously. You just literally throw them out. It means we should do some work here. We should get a representative sample and see what it says, right? So she says, look, the work here, the work in this area is quite problematic. So there's two problems. Then she says there's a third problem here, and she calls this the snapshot gender research problem. And she says, look, one of the big problems with the way in which we conduct gender research in neuroscience is that we do snapshot research. We look at the brain at a moment in time, right? We get some 6-year-olds, we get some 20-year-olds, we get some 40-year-olds, right? And we take that brain at that moment, and then we look at it, and we say, oh, this tells us something about men or women or brains in general, right? So what we're doing right now is that's what we're doing. We're looking at, say, 12, 26-year-old women, 12, 26-year-old men, and then we're going, well, what is the difference between these 26-year-olds, right? We've got a sample of, we've got a sample of men and women. It's, roughly equal. So we should be able to see if there are any gender differences in their brains by just looking at these 26-year-old brains. He says, well, you can't do that because that's a snapshot of a brain. And look, if brain development is pliable and mutable across a lifespan, and it sure seems like it is from, any other, like you learn sort of any brain science, the brain is a highly pliable, highly changeable thing. Just really simple example of that, right? Like if you have like suppose you have a stroke, right? And let's suppose I have a stroke, right? And I had a certain neural pathway in my brain that, allowed me to move my arm, right? And I formed that over the course of my life. Now I have a stroke. I can't move my arm anymore. There's a good chance that I will, with practice, learn to move my arm again during recovery, right? And that's a very fortunate thing is that we can relearn to do many of the things that we lose when we have that, that kind of a brain damage, right? Like even the famous case of Phineas Gage, right? He got better over time. Look him up. But we often don't tell you that, right? When we teach about Phineas Gage, right? But he never got back to perfect, but he did get much better at dealing with his issues eventually. But if I had a stroke, there's a reasonable chance that I will learn to use my arm. But if I relearn to use my arm, it's not because the neural pathway that allowed me to move my arm was repaired. It was irrevocably damaged during the stroke, right? What happens is we form new neural pathways to do the same thing, right? Why? Because we have a pliable, mutable, changeable brain, right? We can learn new tricks, even when we're, ancient like me. And so look, if our brains are pliable and changeable across our lifespans, they sure seem like they are, and if they change in response to our environments, which they sure seem like they do, if you want to make claims about a stable universal sex difference in the brain, which is what all these studies want to do, you can't take snapshot research. Why? Because brains are mutable and changeable, right? If you look at them at a moment in time, you're leaving out everything that has got those brains to that point, right? So you're not at all considering, well, how do the environment and social factors contribute to these brains being radically different, right? So you need something much more complicated than snapshot research. And she says, look, this is what we do. We do snapshot research. And that leads us to substantially biased science that presents false sexist views of the female-male brain. If social and environmental factors influence brain development, and we don't know if they do, but we've got reason to think that they do, right? And we haven't ruled that out. So it's a possibility we need to consider in our research. But if they do, these studies would be self-fulfilling, right? So in other words, right, suppose that there is no biological difference between male and female brains, right? That every difference in regards to our brains is a matter of social and environmental factors, right? That's a possibility. We don't know if that's true or not, but let's just suppose, right? So now what happens, your brain that you end up with as an adult is the product of socialization and environment. We take a bunch of girls and we take a bunch of little girls, we take a bunch of little boys and we raise them, right? And we socialize them. And we socialize them in an environment that, genders them, right? Because, we do that, right? Or at least we think we do that, right? So let's assume that we do that because we're saying, hey, look, social and environment are going to influence our brain, right? So we do that, right? We socialize a bunch of little boys and girls. And then we take a snapshot of them at 26. We've already socialized them. So their brains are now the product of intense socialization and environment. And what do we find at 26? We find that the female brains and the male brains are radically different because social and environmental factors. But we aren't looking at that at all, right? We're just saying, hey, at this moment in time, these women and these men have radically different brains. So therefore, men and women are biologically different. Well, that's not what your data shows at all, right? So example, if you have studies saying little girls like pink and dolls and boys like blue and trucks, and then we socialize little girls by exposing them to more pink and dolls and boys to more blue and trucks, not surprisingly, little girls are going to grow up liking pink and dolls and boys are going to grow up liking blue and trucks. Despite the fact that none of that is essential to being male or female, right? Now, we're not saying, and she's not saying 100% social and environmental factors are what accounts for gender brain differences. She's just saying, look, it's entirely consistent with the data that we have, that's what's doing 100% of the work. We just don't know because we're designing really poor studies. And you need a study that's kind of taking this kind of you need to isolate the cause here. And in our experimental design is just not at all equipped to do that. And so we're coming up with nonsense. And then we're treating it as if we're sort of demonstrably demonstrating essentialist biological differences. And we don't have that. So those are her criticisms of the current neuroscience. So what does better look like? Well, she says the fact that the social phenomenon of gender is literally incorporated, shaping the brain and the endocrine system means the brain that has developed by any snapshot will have been profoundly socially shaped, not essentially shaped. So what do we do to figure out what the actual truth is? And she gives us a bunch in her work. She tries to incorporate the principles of neural entanglement into research models, tries to give us much more complicated models, dynamic models of how we could look at, how it is that biology and environment and sociology all sort of interact. And so we could look at this stuff and we could isolate kind of relevant factors and, give an account. That's going to go beyond this course. But I do have a couple slides sort of going through her research if you want to look into it more. But in a nutshell, what she's saying is, look, the current models are way too simple to study gender brains effectively, and anything that's getting said here is just a pseudoscience, because the experimental design is grossly too simple. We could do better work. We have the tools to do better work. We just aren't. And she says that's unfortunate. Now, I've got these slides. Maybe I'll say a little bit. No, I'm not gonna. Maybe I'll just say a little bit of this one. So like what she thinks is going to be a more reasonable experimental design, right? So, you've got your males and your females at birth, right? And then what you do is you take all these possible things that could influence how they develop over time, right? Like gender socialization, stereotypes, gendered learning, gendered reinforcement, all this different kind of stuff. We need to have experiments that take into consideration these kind of factors in our design, right? And we also need to look at, that's, I think, as simple as I can make it, right? She's just saying, look, you need experimental design where what you're doing is you're taking all these factors and you're looking at them as a dynamic model. And designing things that can isolate and test very specific things that could potentially be causally relevant, but you have to bring them all in. You can't just do snapshots by themselves. If you do that, you're avoiding all the possible causal things, because biology is just one of many causal factors, right? We can't assume it's the thing doing the work when there's all this other stuff that we are pretty sure does some work, maybe all the work. And if your experimental designs aren't taking that into account, it's a pseudoscience. So that's Cordelia Fine. That's probably more than you ever wanted to know about feminist critiques of science. Next week we'll move on to talking about realism, anti-realism, and race. So have a good one.